Morning everyone. My name is Sanjana. Today I am going to present a ATC assignment. My assignment topic is structural and computational representation of C programs. Modern compilers and AI coding assistants do not process source code directly as plain text. They first convert the code into different intermediate representations to understand its structure, control flow, and data dependencies. In this project, I developed a web-based system that accepts a C program as input and generates multiple programs representations such as token table, abstract syntax tree, control flow graph, data flow graph, and code property graph. These representations helps in understanding how a compiler and AI systems analyze source code. This is the introduction of a project of our assignment. Next, problem statement. Students often study automata theory and compiler design theoretically, but find it difficult to understand how these concepts are applied in real-world software tools. So the objective of this project is to create a system that takes a C program as input and visually generates tokens, AST, CFG, DFG and CPG graphs. This helps students understand program structure, execution flow, data dependencies and the practical application of automata theory and computation concepts. So this is the demonstration of web interface. This is the web interface developed for the project. The user enters C program. This is the source code. When a user enters C program in the input text area, in this this is the source code to run all the graphs. I copied this text, this code, and paste it in the input area in this. When I click on generate representations, so I put the program, I paste the program in this and click on generate representations. This first the source code. This source code explains variables a, b, c initialized with 5, a initialized to 5, b initialized to 10, and we declared c to store the result in the c. Condition checks if a less than b. If it's true, then c equals to a plus b. If it is else false, then c equals to a plus b. Next, another in else it will print as c. C store the result, then it returns 0. When I paste the program in this, a token is the smallest meaningful unit of the program. When I paste the code, I click on generate representation. Then it shows lexical analysis and that is tokens. A token is the smallest meaningful unit of a program. Example, token int is a keyword. Int is a keyword, main is an identifier and open bracket delimiter. A identifier equals to operator and phi is the constant. During lexical analysis, the compiler breaks the program into tokens, keywords, identifiers, operator, constants, and delimiters are identified. This is the first stage of compilation. Next, AST, that is abstract syntax tree. This is the generated tree. AST represents the hierarchical structure of the program. At the top of the program node, below it is the main function, and the AST contains variable declaration, if statement, then block and else block, and printf statements and return statement. Unlike source code, AST removes unnecessary symbols such as semicolons and focuses only on program structures. It helps the compiler understand the syntax and structure of the program. This is all about AST, that is abstract tree syntax. Next, that is CFG, control flow graph. CFG represents how control moves through the program during the execution. I will explain step by step. First, it will start, and declarations A is equals to 5 and B is equals to 10, that the result is stored in the C. Then decision condition, that is if A less than, it checks A less than B or not. If it is true, then C is equals to A plus B. If it is false, then it comes C is equals to A minus B. Both paths merge and print the result, whatever it is true or false. Then return the answer and end. It helps identify execution paths, loops, branches, and unreachable code. This is about control flow graph. Next, DFG, that is data flow graph. DFG focuses on how data moves through the program. This is A 5 and this is B 10. These are the values defined to variables. Then it is also checks a condition A and B. If A less than condition uses both variables A and B, then AB uses plus operator and or minus operator. Result is defined in C. Next, it will print the result using printf. It shows how dependencies between variables and operations. This is about DFG. The last one, that is CPG, that is code property graph. It shows CPG combines AST, that is abstract syntax tree, and CFG, a control flow graph, and DFG, data flow graph, into a single graph. This is the combination of all three graphs. In AST provides a program structure. CFG, AST provides program structure, and CFG provides execution flow. DFG provides data dependencies. Combining all three creates a code property graph. This is the graph of code property graph. It provides complete program understanding and is widely used in vulnerability detection and code analysis. These are the all graphs that are represented using this web page. Next, connection to automata theory. This is the most important ATC part. Lexical analysis, finite automata. Token generation is based on finite automata. The compiler reads characters and identifiers, keywords, identifiers, operators, and constants using state transition. Syntax analysis, context-free grammar. AST generation uses context-free grammar. Grammar rules define valid program structure. Next, CFG connection, explain. CFG in program analysis is different from context-free grammar, but both are used during compilation. This is connection. This is connection to automata theory and computation. Next, connection to AI code assistants. This is the very important point. Modern AI coding assistants such as ChatGPT, GitHub, Claude, Gemini do not analyze code as a plain text. They internally build representations similar to tokens, AST that is abstract syntax tree, and CFG control flow graph, and DFG data flow graph, and the last one CPG that is code property graph. These representations help AI understand program structure, variable dependencies, and execution behavior. This enables code generation, debugging, vulnerability detection, and code completion. So the advantages of this assignment is better program understanding and compiler visualization and ATC concept understanding and code analysis and AI code understanding. Next, the last one, debugging support. These are the advantages. So this project demonstrates how a C program can be transformed into tokens AST, CFG, DFG, and CPG. These representations help visualize program structure, execution flow, and data dependencies. The project also shows the practical application of automata theory concepts such as finite automata and context-free grammar, as well as their use in modern AI coding assistants and compiler systems. So this is all about structural and computational representation of C programs. Thank you.